In this example, which is titled example 5, but it's actually the second example following the first one, we're going to do the same thing that we did in the previous example. I'm going to show you a different method, though, that you can use. We're still going to find a vector that's perpendicular to two other ones right here, and we're still going to verify that result using the inner product. In the previous example, I utilized smaller 2 by 2 matrices to find the determinant of a 3 by 3. There's another way that you can do that by hand, and we're going to do that in this example. You get to choose whichever one you like to do, whichever method you want. Each one will work the same. We still start these off the same way by creating a 3 by 3 matrix. The top row is going to be I, j, and k. Those are our unit vectors. And the coefficient of each one of those unit vectors is going to give us our x, y, and z components. Then we write down each vector that we are given. So 1, 3, 4 goes in the next line. And then the last line here is going to be negative 1, 0, negative 1. In this method, we're going to have to repeat two of the columns, and it's going to be the first two. So you're just going to copy down exactly what those first two columns are. Then what we'll do is we'll use the diagonals of each one of these. We're going to go upper left to bottom right first. And what you're going to do then for each one of these diagonals, there's actually going to be 3 in this direction. You're just going to multiply all 3 of those items together. So the first one's going to be I times 3 times negative 1, which is negative 3i. We'll then circle the next group, which is j times 4 times negative 1, or negative 4j. And then we'll continue with the last one here, which is going to be k. And it's 0 times 1 times k, or k times 1 times 0, which is 0k. For the next piece, we're going to do the same thing, but in the opposite direction. And we're always going to subtract each one of those from the previous items we just found, their terms in red. So to use this method, or at least to continue with this method and use the second part, what we've got to do is just draw the diagonals in the other direction. So instead of upper left to bottom right, we're going to go bottom left to upper right. So here for the first one, we're going to have negative 3k. It's negative 1 times 3 times k. And then we'll circle, we got 2 more to do here. So this one's going to be 0i. And then we've got negative 1 times 1 times j here, which is negative j. Then all you need to do is go ahead and combine these. So we have negative 3i, and then it's going to be minus 0i. Well, that's just negative 3i. Move on to the next one, which is negative 4j minus 1j. So negative 4 minus negative 1 is actually negative 3j. And if you're struggling with that part, you can go ahead and just distribute this negative sign, the blue one, all the way across. If you want to do that, that'd be fine too. Then you can just combine terms as needed. The next part is 0k, once again, minus 3k. So 0 minus negative 3 is positive 3. And now what we're going to do is just write this as a vector ordered triple. So that's negative 3, negative 3, 3. And there's your answer. Hopefully, this vector is going to be perpendicular to the other 2 that we started with, the 1, 3, 4, and the negative 1, 0, negative 1. To check that, what we'll do is we'll just take the dot product between each beginning vector, or our given vectors, and the resultant vector here, which is negative 3, negative 3, 3. You don't need to find the dot product between the 2 original ones because they may or may not be perpendicular. Our task was to find a third vector that's perpendicular to those 2. So that's what we're going to check here. If we work the dot or the inner product here, we've got 1 times negative 3. Those are your x's. 3 times negative 3 is negative 9. That's your y components. And then 4 times 3 is 12. If we add negative 3, negative 9, and 12, we get 0, which is good. When the dot product between 2 vectors is 0, it means that they are perpendicular. Now we're going to do the same thing, but just with the second vector. So we did the first one before, and now we're on to the second one here, which is -1, 0, oopsies, -1, 0, -1. Just let me verify that. There we go. And then we're going to do the dot product again with our resultant vector, the vector that we found here. That was in purple from before. So we're going to multiply the x's. -1 times -3 is 3. 0 times -3 is 0. -1 times 3 is -3 with your z components. And when you add all those up, you do get 0. So what we've done in purple is we've found a third vector that's perpendicular to the other two. And those are right here. And then we verify that using the dot product.